Welcome to my channel, everybody. And today in this video here is a small discussion about the infinite series, and it is only the base of class 11 and 12, not upper classes, and some some more students send me the want to know what is the infinite series like GP series, so that's why I make a video about about that. Okay, and now I make some question in my note. So introduce with all of you. See carefully. Infinite series. In infinite series only about the geometric series, and about the study of GP. You know the GP series, that is their Asn. If the series be AR square and dot to AR to the power n. And you know the sum of this series is here A into 1 minus R to the power n by, and this is 1 minus R. Okay. So this is the sum of the JL series when n is a finite. N is a finite. But when n tends to infinity, then what happened? When n tends to infinity, okay. Infinity is a concept of big large number, like this series. So goes to infinity. So which this is not to be countable, okay, and the number of terms, just looking as there is a first term, second term, third term, we read as third, fourth, fifth, 11, 200 terms like that. But the n term means that type of digit term are not to be countable. And if you're thinking it is a 1 lakh page terms, so you're thinking there is a limit as a 1 lakh, but this is also more than your thinking. So that is the concept of n tends to infinity. Then when n tends to infinity, what happened and how can happen this result? See carefully. First of all, I write some note. When n tends to infinity, then S means sums. Only this series goes to a sum and tends to infinity when R is more than 1 and is also equal to R is less than equal to minus 1. But how can it possible? In my next point of view, we discuss introduce with all of you. And when n tends to infinity, then S tends to that is A, and this value would be 0. When would be 0? So this is okay. So A by 1 minus R. See about the thinking of that. Y is more than R, then its value tends to infinity of that. Okay. See here, n tends to infinity. Just small thinking. Then every value like 1 to the power n, this is also tends to infinity, it tends to infinity. Like 2 to the power n, then it's also tends to infinity. Like 3 to the power n is also tends to infinity. Okay, but if it is written by 2 to the power n and it goes to 0, why? See, if the value Bn is equal to 1, then we get here 2. If the value of n put there 2, then we get 4. And if put there 5, then we get 32. So if n, the number of digits we increase, then these value are increased. So same as n tends to infinity, then these value is a big large number. Okay, so that concept, if we divide by 1 by that large number, is close to 0. Actually, directly we not write equal to 0. It tends to mathematically there is a close to 0. So same as like that. So 2 to the power n means this is a big number. So 1 by the big number is close to 0. Let's just to some idea, like if we divide by 1 by like 1, 0, 0, 7, 8, 9, 10, 11 and dot 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 dot, and like here is 100 digit. So 1 by that 100 digit tends to keep close to 0. Okay. So actually we did as this is a 100 digit. So it would be a finite. But there 2 to the power n also a big number, which you have thinking a number like this, which I give an example here. But this also are more than your thinking. So that's why it goes to a 0. So why is this 0? It is clear, all of you. Now, so that's why about that when r is more than 1, about r is more than 1. So 1 is equal to 1 means this is 1 minus 1 is this is not defined, and this is equal to 1. If it is 1, so 1 a plus a plus a plus a. So it like up to n, a n. See carefully. First of all, you discuss about equal to 1. So if you put here 1, 1, 1, then what we get here? A plus a plus a plus up to n, a into n. See, n tends to infinity. So that's why n into a. So it's would be infinity. But if it's more than 1, this is more than 1. Like 2. If we take 2, same as if we take 3. If we take 4, same as this is your thinking is goes to infinity. So 1 minus infinity is the negative infinity, but in the numerator part also negative. Negative by negative is positive, so it goes to a positive infinity. Okay, I think all of you are clear. To all of you. Okay, see again for that, and also if it is less than minus 1, so that is only minus 1, minus 2, minus 3. So it is goes to only a negative, negative, positive, negative, positive. So some not to be countable. Okay, so it is goes to infinity. And now see again, we discussed about when the value of r is lies between that is minus 1 to plus 1. Then what we get, and this is we get here. So r is lies between, this is minus 1 to plus 1. So block this. So r to the power n. So see here, and this is tends to 0. Like in between minus 1 to plus 1, if we get 0.5, for example, we give you a example, and this is tends to r0. Why it would be a 0? Just you think, if 0.5 to the power 2, that would be 0.25. If we 0.2 to the power 4, then we get here 0.12 something. Okay, so if increase this power, then the total value goes to a smaller than your thinking. So what about goes to the small value? Exactly the value would be a 0. Okay, so that's why it's be close to 0. Okay, I think better understood. Okay, so that's why. And so again I repeat, if the value of n are increased, then this value, as it is a fraction, a point value. Okay, 0.5, not 1.5, 2.5, only 0.5, 0.6, 0.9. See here, lies between minus 1 to plus 1. Okay, if we get here minus 0.5, minus 0.5 to the power n, it also goes to 0. Okay, see carefully. So that's why the value of r to the power n is 0. So we can write here r to the power n is 0. So this value is 0. So 1 by 1 minus r. This is your answer. When n tends to infinity and the value of r lies between minus 1 to plus 1. So this is your concept. And some another concept like when, see here, n tends to infinity, then what happened? N tends to infinity, then what is the value of like 2 to the power n plus 7 into 3 to the power n, and by this is here same as 5 into 2 to the power n plus 3 to the power n. What will be the value? So thinking here is you always arrange this formation. Actually, you should arrange a value of the form of which lies between minus 1 to plus 1. So it can be possible here. If we divide it by 3 to the power n, if we divide it by, it is 3 to the power n, then what happened? So it means that take account 3 to the power n, take account 3 to the power n on the numerator and denominator part. Then we get here like this here, okay? And this is 2 to the power n by 3 to the power n plus 7 here. So 5 into 2 to the power n by 3 to the power n plus 1 here. So these two values are cancelled. So you get here 2 by 3. So see, 2 by 3 lies between minus 1 to plus 1. So concept is this here, what happened? So r to the power n tends to 0, okay? So this is approximately 2 by 3, approximately 0.66 something, okay? So this is to the power n. So plus 7 by 5 into 2 by 3 whole to the power n plus 1. As we see, n tends to infinity. So increase your power, then these values are goes to a 0, okay? So that's why it is be 0 plus 7 by 5 into 0 plus 1, then value will be 7 here. Okay, so this is your concept. Again, another point lies here, root over 0.444, okay, dot dot dot, and this is equal to 0.666, okay. So see, for this we can left hand side we can write here. This is a number 1 point, and this is a number 2 point, and this is discussion about the 3 point, and number here is 4 point. And see 444. So now write here 4 4 4 dot dot to this. So you can write here 0.4 plus 0.04 plus 0.004. So this is an infinite GPC, and the value of r lies between minus 1 to plus 1. So you can apply the sum of that a by 1 minus r. See carefully. So if we divide this by this, then r is equal to 0.04 by 0.4, and that is equal to 4 by 100, and this is here 10 by 4. So this is there 1 by 10 only. So see, the value of r lies between minus 1 to plus 1. So that's how you can apply the ratio a by 1 minus r, and that is equal to a means 0.4 here, and 1 minus r means this is 1 by 10 here. So this is, take a LCM, then we get here 4 by 9. So this is your and this is your root over of 0.444, okay? Then we get there 4 by 9, and this is here 2 by 3, okay? And now on the right hand side, and see 0.6666, same as 0.6 plus 0.06 plus 0.006, okay? So now see here, this is your 0.6 divided by 1 minus r. This divided by this, here is r means 1 by 10. So that's why we can write 6 by 10, and this is 9 by 10. So 6 by 9 here. So you can write here 2 by 3. See, this also 2 by 3, and this also 2 by 3. So left hand side equal to right hand side is proved. Okay. Now the another discussion about if x is equal to this is your 5 number point, 1 plus a square plus b and order to infinity, and also y is equal to 1 plus b square plus order to infinity. So we want to then prove that yeah, find the value of, we can write here 1 plus AB plus A square B square, okay, dot to infinity. Find the value of that. So from here, see, and the value of A and B, both of them are lies between -1 to +1. So we can easily use the formula is this, okay. So that's why from that we can write here 1 by 1 minus A, okay, we can write same as y is equal to 1 by 1 minus B. Okay, see again, for the series here, 1 plus AB plus A square B square and dot to infinity, we can write here 1 by 1 minus AB also. As A comma B lies on -1 to +1, so therefore the product of AB also lies on -1 to +1. And clear view, if -1 to +1 lies between -1 to +1 AB, so let us assume 0.5 and B also 0.9, then both of them multiply, this also lies in between -1 to +1. Okay, so you can write here is this. So what is the answer? 1 minus A, find here A. From that we can find A is equal to, this is 1 by x, so A is equal to 1 minus 1 by x here, same as B is equal to 1 minus 1 by y here. Okay, same pattern we are looking here. So AB, so you can write here 1 minus 1 by x, so 1 minus 1 by y. Then take a LCM, then what we get here? Take a LCM, then we get xy here. So there is xy, so minus x minus 1, and this is y minus 1, okay. And multiply and simplify this figure, so we get the answer here. That is, we can write here xy, and then we get xy minus xy, okay. So minus x minus y and minus minus plus 1. So we get here xy by this is your x plus y and this is minus 1. So this is your answer. Okay. So now next point we want to discuss, all of you see carefully. This is here looking 3 to the power 1 by 2, and this is 9 to the power 1 by 4 and 27 to the power 1 by 8 here and 81 to the power 1 by 16. So dot to infinity, and its value, what is the value of that? Okay. So see, so let us assume this is as a s. So s is equal to 3 to the power 1 by 2. We can write here plus, and we can arrange this number 9 to the power 1 by 4, that is 9 3 square. So 3 to the power 2 by 4, okay. And again add the number, the base are, we have transferred this base as a 3. So second part is 3 to the power 2 by 4, and third part is 3 to the power 3 by 8. Okay, 3 cube, this is 3 by 8. Okay, and the power we added like that. 81, that is 3 to the power 4. This is 4 by 16. Okay, dot to infinity. First find this. Let us assume is a P. Okay, is a product, so this assume as a P. So the power is here is, let us assume 1 by 2, 2 by 4, 3 by 8, 4 by 16, and dot to infinity here. Okay, then see, except 1 2 3 4, like that 1 2 3 4, then the in the denominator part there are 2 4 8 and 16. See, the 2 are increased, so in the ratio as 1 by 2 here, so that's why I want multiply by 1 by 2 on that series, so multiply by half. Okay, then we get here 1 by 4, so write here 1 by 4. If we multiply by 1 by 4, then we get here 2 by 8, okay, like that. If we multiply 1 by 2 here, then we get here 4 by 16. So just multiply 1 by 2 on the both the sides, then we get here this, okay, and dot to infinity. So doing minus, doing minus, 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 minus. Then what happened here? A is minus, A is by 2. And this is here 1 by 2. If we subtract this, then we get here 1 by 4. Subtract this 1 by 8. Subtract this here, I think this is a small mistake, 3, 4, this will be 3, okay. So this is here 1 by 16. So now, looking at infinite GP series, okay, infinite GP series we get here. So this is here on the left hand side, A is by 2. So this is half and this is 1 minus this by this by this is as a half. So see, the value of r lies between minus 1 to plus 1. Okay, that is half. Okay, we can apply these rules. So this is here 1 is by 2 is equal to this, so is equal to 2. So P is equal to 3 to the power 2, that is 9. So this is your answer. Okay, see carefully. Very interesting question. Okay. So now look at another point of view. So yes, this is all. Okay, see here. I think it will be complete. Okay. And number 5 here. This is here 6 and 7. Okay, this is the last question. If x is equal to summation 0 to infinity, and this is cos theta to the power 2n, and same as y is equal to summation n equal to 0 to infinity, then tan phi to the power 2n. Okay, and z is equal to summation 0 to infinity and sin theta to the power 2n and tan phi to the power 2n. Okay, where theta and phi lies between pi by 4, 0 to pi by 4. Then find the relation between x, y, z. Then find the relation between x, y, z. See, find between x, y and z. See from first. So see, the series is, if we put 0, summation means if we put 0 then we get here 1. If we put 1 then we get here cos square theta. If we put 2 here then we get here cos square 4 theta. See student, okay. Then sum is here 1 by 1 minus r, you know. This is r, this by this, r means cos square. So this is here cos square theta and this is here 1 by, so sin square theta. Okay, same as y. Look here, if we put 0 then we get 1. If we put 1 then we get here tan square to phi. Sorry, this is phi, and this is here 4. So again we get there 1 by 1 minus tan square phi here. Okay, so find tan square phi. Actually of that series we can use directly tan square phi also. So we can find here that is 1 minus tan square phi is equal to, this is here 1 by y. So we can write here tan square phi is equal to, this is here 1 minus 1 by y. Okay. So actually want to see where, in what place you can write this. So x, y and z are fine. Okay. Now from here z. So here I can write z is equal to, this is z, see, This is also same as 1 by 1 minus theta, and here tan square phi. Just we put the value where sine square theta on that. So this is equal to 1 by, this is c sine square, this is 1 by x, this is there x, sine square is 1 by x. So 1 minus 1 by x, and c tan square phi is here 1 minus 1 by y. Okay, and simplify. So this is your answer. Okay, this is your small discussion about the infinite series. See carefully, students, for the class of 11. Okay, bye. I think all of you are better understood.